Hi everyone. So today I'm going to discuss the third step of our section. Now we already have discussed about limits. Then we have discussed about continuity. This is the third step. We call it as derivatives. So as an example, it is like a step. This is for limits, and this is for continuity. This is for derivative. To discuss about continuity, we need limits. So discuss about derivatives, we need to learn this continuity. So these all are connected, and this lesson is flows like a step by step. So you need a good understanding about limits, then continuity, then derivatives. Okay, first upon all, to discuss about derivatives, we are going to discuss about rate of change. So this is called average rate of change. This has two parts. First one is average rate of change, and second part is instantaneous rate of change. So first, let's learn about average rate of change. Already I know you have learned these things in 1330 lesson. Now I am going to memorize these things. So now let's look at this one. You can see I am going to find average rate of change this function. This function is y is equal to f of x. uh, I'm going to find average rate of change in between a and b. Here a is our starting point and b is our ending point. To find this rate of change, we need to take a ratio first. This is the change of this function in between a and b, and this is the change of this given independent variable. This is the change of dependent variable, or this is the change of function, and this is the change of independent variable. This is the basic idea. So it gives geometrical representation, means it gives a segment like this line. Okay, now let's look at some example. So this figure 9.18 shows the presence of elderly men of elderly women in the workforce in selected years from 1970 and projected to 2040. Now find and interpret the average rate of change of the present of elderly men in the workforce and elderly women in the workforce from 1970 to 2040. So this is two categories. We need to speak about men and women separately. So first I am going to find average rate of change of elderly men. So we need to understand what is our starting point and ending point. So this is our starting point and this is our ending point. So this is our A and this is our B. And if A is this value 26.8 and if B is 17.3. So now you can see it. So we already have applied for this formula FB minus FA divided by B minus A. So we can obtain this ratio, and using your calculators you can obtain this one. So it is negative 0.136 percentage points per year. Now I am going to find average rate of women in workforce in between 1970 and 2040. So it is in this rose color for women. Our starting point is this one and this is our ending point. So this is our FB 9.7 and FA is 10.1. Okay, now let's go to our calculation. So you can see this one. Here also FB minus FA divided by B minus A. I think this is an easy task for you. Try to do by yourself. Uh, Now let's go to discuss about instantaneous rate of change. Actually, the difference between average rate of change and instantaneous rate of change means average rate of change is the rate of change in between some big period, and instantaneous rate of change means rate of change in between some slight little period. As an example, think you are traveling from Lubbock to Dallas. Uh, let's take the distance is, approximately 500 miles. This is Lubbock and this is Dallas. So total distance is 500 miles. Then you need 10 hours for this travel. So your average speed becomes 15 miles divided by 10 hours, so it is 5 miles per an hour. This is the average rate of change of your speed, but instantaneous rate of change means speed at each point. So in this point you have some instantaneous rate of change, in this point you have some instantaneous rate of change. So the idea is instantaneous rate of change means that rate of change in that slight moment or that slight point. Okay, so especially here we concern our 2 points, as in this moment x is equal to 1 and x is equal to 1 plus h. So this is our A and this is our B. If we represent the change in the time by h, then the average velocity from x is equal to 1 to x is equal to 1 plus h approaches the instantaneous velocity at x is equal to 1 as h approaches 0. I think there is no need to worry about this one so much. Let's look at some example, then you can understand this phenomenon. So first we are going to discuss about a motion of a ball that has thrown straight upward. Suppose a ball is thrown straight upward, so that its height f of x in feet is given by the equation. This is the given equation. F of x is equal to 96 plus 64 times x minus 16 times x to the power 2, where x is in time in seconds. So first you need to find average rate of velocity. So it is the average rate of change from x is equal to 1 to x is equal to 1 plus h. So find this one, f of 1 plus h minus f of 1. So this is f of 1 plus h and this is f of 1. Then you need to simplify by yourself. Finally you can obtain this one. So this is the difference between 1 plus h and 1. Then we need to find average rate of change. This implies average rate of change PAV. So 1 plus h minus 1, it becomes h. So finally this is the average rate of change. So to obtain instantaneous rate of change, always we need to take the limit of h to 0. So finally this is the instantaneous rate of change. So it is 32 feet per second. So it is the instantaneous velocity, and this one is the average velocity. So you need to remember that to find instantaneous rate of change, first we need to find average rate of change. Okay, now this is the given derived formula for the velocity. So it is the first, this section is the average rate of change. Find average rate of change in between these two intervals. Then take the limit that h goes to 0. This is the instantaneous rate of change. So we call this as the instantaneous velocity. Here h is in time and this f is the distance. For the general idea of the instantaneous rate of change, we call it as the derivative. So now you can find the derivative of a given function. So the process is, let's look at step by step by looking at some example. So to find the derivative of y is equal to f of x at any value x, let's see. So step 1, let h represent the change in x from to x plus h. So you need to find this one, f x plus h minus f of x. So substitute for your function, it is 4 times x plus h square minus 4x square. So finally you can obtain this one. Then from the different quotient you have divided by h. So this is the average rate of change. This is 8 times x minus 4h. So finally, to take the derivative, you need to take instantaneous rate of change, then take h to 0, take the limit of h to 0, then you can find it is 8 times x. So this is the derivative of this function for x square. So doing more examples, you can obtain this.